This is a classic problem about related rates. Suppose that water is flowing into a tank that is a rectangular prism with a square base of length 20 meters. If the water is flowing in at a rate of r of t is equal to 1 over 10 sine of t plus 1 over 10 cubic meters per second, at what rate is the height of water in the tank changing? At first glance, this looks like a very complicated problem. However, if we proceed slowly and carefully and write down what we have and what we need, it will become a lot simpler. From the statement of the problem, what we have is the flow. This exactly says that we know the rate of change of volume. If we call V of t the volume, then what we know is V prime of t. The quantity we want to figure out is the rate of change of height. If we call the height h of t, then what we want is h prime of t. Even though we now know what we have and what we want, this problem can still be a little bit intimidating. It's best to get a game plan of simple steps. First, draw a picture. Second, write an equation that involves both the height and the volume. Third, differentiate that equation. Fourth, solve for h prime of t. Now let's go draw a picture. The key phrase we need is that we're working with a rectangular prism. Our water tank is in the shape of a rectangular prism. It has a square base of side length 20. Water is flowing into this tank, and so the height of the water is changing with time. Let's use this picture to write down an equation for the volume. The volume of water in our rectangular prism is given by the area of the base times the height of the water. Therefore, the volume, V of t, is equal to 20 squared times the height, h of t. This expression is easy to differentiate on both sides. On the left, we have V prime of t, and on the right, we have 400 times h prime of t. Rearranging the last equation tells us that h prime of t is equal to 1 over 400 times v prime of t. Remember, v prime of t was the rate of change of volume, which was the flow, and that was given. It is equal to 1 over 10 times the sine of t plus 1 over 10. Therefore, our final answer for h prime of t is 1 over 4,000 times the sine of t plus 1 over 4,000. The units for our rate of change of height are meters per second. That's because the height is measured in meters, so differentiating with respect to time gives us meters per second. Let's do a quick recap. In the statement of the problem, we have the flow of water, which is V prime of t. We want the rate of change of the height, which is h prime of t. Our water tank is a rectangular prism. It has a square base of 20 by 20, and the height of water in the tank is given by h of t. The volume of water is given by the area of the base times the height. Therefore, V of t is equal to 400 times h of t. We differentiate both sides of that equation to introduce V prime and h prime. Our equation now reads V prime of t is equal to 400 times h prime of t. Rearranging this line gives us h prime of t is equal to 1 over 400 times v prime of t. And remember, this is the function that was the given flow, which is v prime of t.